Hello guys, today we will be looking at a very basic algorithm, I can say. Well, it's not basic algorithm, I'll say it's the first algorithm that everyone learns when they join machine learning, which is known as linear regression. Now, what is linear regression and what is it's used for? Linear regression, basically as the name suggests, is used for regression problem, and it is a supervised machine learning model. Okay, simple. And how it works? Let me just show you with an example. Suppose we have some feature 1 and suppose we have feature 2. Okay, and let's say feature 1 has some value like maybe something like 80, 70, alright, 60. Sorry for the bad handwriting. See, I'm not using any pencil tool, so writing can be bad for sometimes. Okay, 80, 70, alright, maybe 90, maybe 100, 120. Assume it to be like weight. Okay, let's say it's weight. Okay, it's weight of a person. Okay, simple, easy to understand. Now let's say we have one more feature here, that is height. Now height is our basically dependent feature. Height is what we are going to predict. Okay, weight is what? Our independent feature. That does not have any relation with the height, but height has relationship with the weight because it is going to predict height. A model will be predicting the height on the basis of weight. Let's assume we have values here in this manner. Okay, we have 150, then we have 170, and we have 175. Okay, then we have 180, and this is in centimeter. Okay, then we have 190. So basically this is what our values are. Okay, now see, if we are going to plot a graph, we know that we actually use a linear equation, which is denoted in this manner. Okay, y is equals to mx plus c. Okay, we use this equation. This is a basic equation that we also have that you must have read in your 12th. Okay, so basically y is equals to mx plus c is our linear equation for plotting a graph, where m is slope, x is our x-axis, y is our y-axis, and c is nothing but intersection. Okay, c is what? Intercept. Okay, now if you plot a graph with this equation, how it is going to come up? It is going to be presented in this manner, right? For some values of weight, we will get points here. For some value of weight, we are going to get points here, height points here, here, and this is how it's going to be look like. Okay, now what does it actually explains about the data itself? It is saying that for a, let's say weight is here and height is here. Okay, for suppose let's and here in this point we have weight 80. So what it is saying is that if we have 80 here, okay, our height would be 150. Okay, this is our actual point. This is what? This is our actual point. Okay, clear enough? Now, what our task is to do in a linear regression model is to create a best fit line. Linear regression model creates a best fit line. Okay, and it does not necessarily need to be starting from a 0. I'm just explaining it in this way. Okay, this is easy to visualize. Okay, so basically what is our best fit line? A best fit line is the line, or basically it is a line actually created by joining all the points, or I can say predicted points, which has the least or the minimum amount of error between the predicted and the actual values. Got it? There would be some distance between these values. obviously I have not like, this is not a proper diagram. There will be some distance, there will also be going to be some actual values which are going to be far away. So but the majority will be residing through this best fit line. Okay, that is how our actually linear regression model works. Okay, easy. This is what, this is our predicted values. Now how we represent the predicted values equation? Okay, now as you can see, y is equals to mx plus c is what? It is our actual values. To basically plot our predicted values, we will use y naught is equals to mx plus c. Simple, nothing difficult. Now in research papers, okay, in research papers we do not use these equations, or you can say these notations. What we use is, we just convert this notation into this format. Okay, what we use is, we use h theta x, okay, equals to, and what is h theta x? It is hypothesis. Okay, it is hypothesis. I'll write it down later on. Let me write in this way, hypothesis. Okay, cool. And how we denote it? We are going to denote it in this fashion. Okay, h theta of x, I'm really sorry for this trouble, but yep, h theta of x is equals to theta 0. Theta 0 is what? C, basically the intercept. Okay, theta 1, what is theta 1? It is slope value. Okay, theta 1 x1. Okay, now if we have multiple features, how this hypothesis will work? Just we will increase the features here. Okay, theta 0 will remain the same, just we will increase theta 1 x1, theta 2, sorry, my pen actually got removed, theta 2, okay, x2 again, and in similar fashion we will just be adding all these theta 3, x3, right? Hope so you actually got it. So basically we will be doing like in this fashion. Okay, so basically theta 1 x1, theta 2 x2, theta 3 x3, so all these will be like having these type of values. Okay, now till theta and xn. Okay, simple. Let me just erase it so that I can actually, or I'll just go down. Okay, now for now we are just considering it to be a basically two feature thing. Okay, just one dependent and one independent for now. So basically it would become easier for us to actually do it. Now as I told you, linear regression does nothing but it actually creates a best fit line. Okay, what it does, it creates a best fit line, and this line is what it actually tries to predict the values as close as to the actual values, and this type of line actually occurs when it actually able to do it. If it is performing well, then it will actually work fine. If it not, then there is some issue. So it will try to create this best fit line here. Okay, so for all actual values, the predicted values should be having the least amount of error. Okay, this difference, okay, the difference between this point and this point should be in less amount. Okay, now obviously how we will know that how to basically place this best fit line so that it will contain all the majority amount of actual values. Okay, how we will actually create this best fit line basically. Now to do this, we have a concept known as cost function. Now what is cost function? As the name suggests itself, it is the function which is basically actually telling you the margin error. Okay, or basically you can say that error rate. Okay, if we want our model to perform the best, or if we want to find the best fit line, basically we need to reduce this cost function as much as we can. Now how the cost function looks like, it is denoted by j theta 1. Okay, it is denoted by j theta 1 okay equals to 1 by 2m. Now don't misunderstand this m with the slope. I'll tell you what is m is, okay, and how it basically why we are using 1 by 2m. I'll also tell you that. So what we are actually calculating here is we are actually calculating the difference between this, okay, and how we are calculating this? By joining these points, right? What we can do is we can just simply see that the difference is going to be in this manner, right? So we are actually going to calculate 1 by 2m h theta, which is the difference, this point, right? H theta of x, h theta of x is nothing but this predicted point. Now minus y, okay, and then I. So h theta of xi, yi, and obviously for all this, okay, summation m I is equals to till the end numbers. So basically this is how it is going to be look like, okay. Sorry, it's not properly, I have not written it in a proper manner, okay. I'll write it down again. No, don't worry. So what is my equation is 1 by 2m. Why 2m? Because look how it comes from this, okay. So basically d by x square, we know that differentiation of x square by dx is nothing but 2x, right? This is what we know. So this is what we are actually doing here. So basically we are doing d by m by dm. So basically we are getting 1 by 2m, okay, simple. Now basically how it looks like is summation of I equals to 1 till m, all of the m, and basically it will be looking like this, okay. H theta x minus, I'm really trying so hard for actually writing properly in this notebook, but it is difficult to write it through mouse, okay. H theta x minus y, and what is this y? These are actual points, okay, yi. These are what? These are our actual points. I'll show you how to place it. Now because we if consider this, if our h theta x value is small, okay, let's say it is minus 1 and our y actual value is minus 2. Now our value here will become negative, right? We don't want this negative value. So what, to basically remove negative values, we actually do a square of it, okay, simple. Got it? Let me just replace it, remove it. Yep, so got it. And to basically get the least amount of error, we need to reduce this cost function as much as possible, okay. Got it? Now if suppose we have these data points, okay, let's say 1 comma 1 is there, okay, 2 comma 2 is there. Now what is 1 comma 1? 1 is our x axis, y, and this one is our y axis, okay. Now this is our actual values, right? This y axis basically what our actual values, okay. Now here I can write just 3 comma 3, okay, simple. Assume we have these 3 data points. Now if we have 3 data points, then m is equals to 3, okay. So what is m? M is nothing but data points total, or total data points. Got it? What is m? M is our total data points. Now understand this, that if we are having actual values as 1, what we are left to calculate, so that we can calculate the theta, basically the cost function, okay. We need h theta, right? H theta of x, right? So how to calculate that? H theta of x, we know, is equal to that equation which I told you before, theta 0, theta 1, x1, right? So what is our x value here? 1. And let's consider for slope, let's consider theta 1 is equals to 1 for now, okay. Similarly, we will also consider it for theta 1 is equal to 0 and theta 1 is equal to, these are randomly chosen values, okay. So you can choose anything here. Theta 1 is equals to let's say 0.5. These are my three values that I have chosen for now, okay. So with respect to these three values, what will be my h theta of x? For theta is equals to 1, my h theta of x will be coming somewhere around 1, basically 1 multiply 1 is 1, and because we are drawing it in a 2D plane, our c or intercept will be 0, okay. Similarly, for 2 comma 2, what will be my h theta x? 2, okay, 2 which is x1 multiply by, what is the theta 1 value? Theta 1 value is 1, 2 multiply 1 is basically 2. So h theta of x will be 2 for this equation. Similarly for 3 it will be 3, okay. Simple. Now consider this, okay. Let's say I am having theta value 0. Now what will be the multiplication of 0? It will be 0, right? So for theta 1 is equal to 0, for theta 1 or slope is equals to 0, my y predicted as theta x or hypothesis basically, okay. You can use any term you want. You can also write it in this manner also if you want, okay. The both of these things are same, okay. Okay, h theta of x is equals to what? For 0 it will be 0. Similarly for the other also it will be 0 and it will be 0. This is what? These are our y predicted values. So clearly you can see that our actual value was 1 here, but it is predicting 0, right? In this it is actually predicting almost pretty much right, but it is going to be get overfitted as this is our train data test. I'll tell you later on these things. You don't need to actually understand this, leave it, okay. But just understand this. For this is, it is actually giving us 0, okay. Now similarly in this fashion, for 3 comma for basically theta is equals to, theta 1 is equals to 0.5, what we are going to get as theta of x it's so difficult to write in this manner. As theta of x is equals to 0.5, okay, multiply by what? X1, that is 1. Similarly 0.5 will be multiplied by what? 2, then 3, okay. And what we will get here? Simple multiplication. We will get 0.5, we will get obviously 2.5 is 1, and then we will get 1.5. So we are getting these values, okay. And when we are going to plot this in a simple graph, okay, let's say in a simple graph, okay, what is our actual values? Our actual values are this, not this. Let me just plot it in the proper way. Let me just plot it in a proper way. As much the best I can do is this, okay. So don't judge my plotting skill. I'm not good with actually drawing through mouse, okay. So what is my actual points here, okay. So my actual point is somewhere here, 1, for 2, for basically for 2 is 2, and for 3 is, it is 3. And for the first instance, for theta 1 is equals to 1, how we are getting the values? We are actually getting the values in this manner, right? We are actually getting the predicted values itself. So we are getting the best fit line to be this one. For theta 1 is equals to 1, okay. This is what we are going to get. Now for this particular instance, for theta 1 is equals to 0, what we are going to get? We are going to get something like this, okay. But this is not good. This is having too much error, right? And similarly for theta 0.5, we are going to get a line something in some way like this, okay. Why? Because theta 0.5 will be somewhere here, okay. And then again this will be here, this will be here. So basically just a bit before these points, and it will be something in some way in this manner, okay. Now how to choose which best fit line is good for our model, okay. For this I told you we use cost function, so we'll just use the cost function now. Basically we'll see how it will actually work. Okay, let me just create one more graph here, and this graph will be for cost function versus theta 1. Okay, so cost function versus theta, you can write it in this manner. Okay, now when we are going to calculate, as we can see here, these are our values for h of x, h theta of x. Okay, now when we are going to calculate 1 by 2 m, okay, summation of basically h theta x, alright, minus y I whole square. When we are going to calculate it, what our values will be? Our m is 3, so it will be 1 by 6, and here we will, for the first instance, we will get 0 plus 0 plus 0, right? Why 0? Because obviously you can calculate yourself also. See here, in the first instance, for the theta is equals to 1, we are having 1, we are having 2, we are having 3, right? Our y pred, or basically the h theta x value. 1 minus the actual value is 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0. Okay, simple. Now similarly in theta 1 is equals to 0, we are going to get it. Similarly in theta basically h theta x, what we are going to get? We are going to get in something like this. Okay, 1 by 6. Okay, h theta of x is 0. Okay, minus 1. Alright, plus this whole square, plus what we are going to get? Again 0, minus 2. Alright, again plus, I'm going to get minus 3 whole square. Right, and this is what we are going to get. This is after calculating this, we will be getting something like this: 1 plus 4 plus something like 9. Okay, and then 13 plus 1 12, and then we will just get something somewhere around 2. Okay, and similarly we will get all these other values also, like this will be somewhere around 3.5 or something like that. You can calculate these values. Basically I'm not going to go into that much detail, but when we are going to plot these values, basically j theta, all the values that are going to come with respect to the theta 1, then we are going to get a graph something like this. Okay, we are going to get a graph something like this. Okay, now after getting this graph, what the problem with this is that we use a formula. Basically we use convergence theorem here now. Okay, now you might be asking why we are going to use convergence theorem. Actually we use convergence theorem so that in this particular place we can actually reach to our global minima. Okay, where we can reach to our global minima. So it actually says that what should be our theta values, or what should be our theta value that we are selecting in the random. Okay, that should be used to actually reach at our global minima, or it is also known as the convergence theorem. Okay, the convergence theorem gives us what? A gradient descent. Okay, gradient descent is nothing but this thing. Okay, gradient descent is this thing. Okay, gradient descent. Now when we talk about gradient descent, how it looks like, we actually try to get all the theta values we can. So how we denote the convergence theorem? Let me just show you the formula first. It actually says theta of j is equals to theta j minus, okay, alpha. Now what is alpha? Alpha is our learning rate. I'll explain you what is the use of this alpha. Okay, differentiation of d theta j, and here we have j theta or the cost function. Okay, and after getting basically this is j theta here. Okay, this j theta here is nothing but what we are getting from here. Okay, basically these values, points. Okay, this is the slope. Okay, you can say it like this is like slope. Okay, now obviously when I am saying that this is the slope, we can have two slopes. Either it can be the positive slope or it can be the negative slope. Okay, this part of the slope obviously it is decrementing, or basically it is going towards this way, so it is a negative value. Okay, this is the negative slope. Okay, and this here is actually increasing, so this is the positive part of it. Okay, now what theta value should be the best theta value that we should use, okay, to basically get the best fit line? Obviously the theta value that is actually here, the global minima. And how to reach the global minima? For this we are using this convergence theorem. Okay, which slope we should use to basically reach till hit global minima at random. Okay, now how to calculate it? Basically this is our learning rate here. Okay, so learning rate is nothing but alpha is equals to our learning rate. And learning rate is a very small value. Okay, sometimes we also say this function to be as optimizer. Okay, optimizer, gradient descent optimizer. Okay, let me just erase it. Hope so I am able to explain these concepts to you. I'm trying my best. Okay, so try to understand it. If you are not able to understand it, just repeat the video. If and if you want to just revise it, you can actually speed it up also. So alpha is nothing but it is the learning rate. Okay, and learning rate is a very small value. Okay, it is what? It is very small value. Now assume this, we are having this equation, right? Now I told you that the slope can be either negative or positive, right? Now let's say we are in a negative slope. Okay, how it will actually choose the theta j value? Now it will, what it will do is, let's say we have a theta j, we have a negative slope, we are in a negative slope. Obviously the negative slope will have a negative value, right? Now negative is our slope, we have this alpha here, we have theta of j. Okay, we have theta of j minus, okay, obviously this theta value or this theta 1 value is going to be nothing but basically this value when basically negative is what? Positive, right? Negative is what? Positive. So whenever my value is going to get basically negative here, basically we are going this way, we are actually going to move towards this way always. Okay, so basically we are going to move like this. Okay, but this will only happen when we have this learning rate to be the least, or basically to be the smallest. Okay, why? If our learning rate is higher, this will not go in this fashion, it will go in something like this. Okay, this will go like zigzag way. Okay, not in this fashion, and it is a possibility that it will never reach our global minima, and we will never be able to find the best optimal value for our best fit line. Okay, so for this we use alpha as the our smallest value. Okay, and then we can actually see that when we have a negative slope, it will start to decrement it, and when we have a positive slope, it will start to increment it. Okay, how? Because negative alpha, sorry, I think I said something wrong. So basically when we have negative is positive, so it will start to basically go this way. Okay, it will start to basically go in this manner. Alright, and when we have a positive value, obviously it is going to get negative when we are going to do this, so it will start to reverse it. Basically it's try to reach here. Okay, got it? Simple. This is what our convergence theorem actually does to our j theta and theta 1 plot. And once we reach to this global minima, then we are able to find that our best optimal theta 1 value, and then we can substitute it with the m value, and we will get our best fit line, which will be having all the points, all the actual points very close to it. So this is the linear regression. I hope so you were able to understand it, and thank you for joining in. And if you like this video, just click on subscribe button, turn on the notification bell, and that actually motivates me to create more videos like this. Sorry for the handwriting, because I don't actually have that writing board or something like that. I was trying to basically do it in the notebook also, but there was issue with some camera handling. But I'll try to basically create the more videos like this and try to basically improve my handwriting with mouse also. Hope so you were able to learn something, and have a great day. Tada, bye bye.